All right.
All right.
Well,
Well,
thank you.
Mark, why don't you and your team take it away?
Yeah, thanks. Um, so we've been using Akka.net for a couple years, and I started off writing the code, and TJ has taken over. But so I'm going to start just because I have a bit more history with it, and then TJ is going to talk, and then Kyle just joined the team, and so he's just here to get used to going on air like this. So that's what we're about. What we do is we run in. We talk a lot about Azure, so we run in Azure all the time, 7 by 24 as a app service, C sharp, of course, and we're we do self configuration. So a lot of our code just on self configuration or zero configuration. We designed a lot of these components when a new attack vector, which is still out there, was people would join. I had joined SolarWinds GitHub, and it happened to other products. They joined the dev team, except they were bad guys, not good guys, and they looked like they were developers. And that product, SolarWinds, is on a lot of computers. So we changed our architecture at that point to be self-configuring, so there's no APIs on it, and that just reduces the attack surface. And then we write to a built-in database in Azure called Log Analytics Workspace, which we can stream a lot of data to it, and it ages out. It's not super expensive, and it's got a lot of nice ways to get the data out and querying it. So that's what we're zero configuration. So we start up, we run as an admin level so we can probe the system. And then once we understand where we're at, we gather a lot of data and analyze it. It takes a while to analyze the data. It could take a few days. And once it's analyzed, then we run more slowly in the background. We're designed to be lightweight, so it is a command line product that we just host on ASP.NET. So it's like it's a service. And we want it to run everywhere. So we scale out with it with cache. Right now we run with a single instant cache, but it's designed to work with larger caches as well. Or there could be a lot of them running, or one large one running, and it does multiple tenants. So that's kind of the architecture. And I'll go into more details on how we use Akka.net. So just quickly on us is we are fortunate enough to get some good recognition from Microsoft recently at RSA. So that was nice to see for a startup to get that. And we do work with them closely, and we try and extend what they provide and make it get some edge cases, but also maybe make it a little easier to use. There's a lot of labor with Microsoft security, so we're trying to automate a lot of the labor that's there. Microsoft and other companies produce a lot of data, so we grab that data and then correlate it and clean it and make sure that it's good solid data.
So we'll
go more into that.
So if I can ask a stupid question, speaking as someone who is not a security expert, what are the sorts of types of problems that you try to find basically inside these solutions so far, or are you getting to that later? I apologize if I jumped the gun here.
We'll touch on that, and then Thomas will drill into it more with some examples.
Okay, gotcha.
So one common one right now is, of course, most people in the cloud attack through a user account, and that's usually password spraying or things like getting a hold of their browser if they go to a website or something and getting a password. So people are really trying to get to MFA. Everyone's using MFA now, of course, not everyone, but a lot. And there's ways to configure incorrectly where someone may not always get MFA, and that would be a risk, especially if an account that's not used very often but has a little bit of admin privilege. So it's kind of sitting around, and then someone password sprays, let's say, and they get a hold of it. And maybe it's an older account that didn't have the best password policies. So now they're in your system and you don't quite know that. So the best thing is to prevent that. So in that case, we would run through all your users and could look, even the ones that haven't logged in recently, and we would find out that, hey, here's a user that doesn't have any rules, or here's a user that hasn't logged in a while, and maybe you want to disable that account, for instance. But that's a real easy way to get rid of a fair amount of risk.
Got it.
Okay. So I'm not a big fan of builds. I always go one too far, so I try to get rid of it, but these things get taken out. So why did we go with actors? I'll start with that. So I've done a lot of these. These are, some people call them scanners, but the way the industry is heading is they run all the time. And we continually stream data out. So it used to be, maybe even people still do this, once a quarter, they may hire a firm to come in and do a scan and get a big pile of data and then look for a few problems and wait for the next quarter. But the way the industry is, there's so many, Azure's always changing, and inside of companies, people are getting different, joining different management groups or whatever. But a computer group is a collection of users, that kind of group, and all that changes their profile. So things are always changing. So you need to be alerted more quickly. So it always runs, and if our software isn't running, it may not report anything, and people might think it's okay because it's not running. So, and we can't send a message we're not running. So the thing, because I guess you could with like a watchdog or something, but we don't do that. Instead, we use Akka.net to, one of the first things I liked about it was the robustness. And I tested it quite a bit. And, crashes, you force a crash, throw an exception, whatever, and then it run, it does restart quite nicely. So that was a big thing for us to keep it running. Of course, we want to keep our software really light, so it's nice. It runs, and it's .NET 6 server, so it's portable, and that was the first reason we went to actors, is the robustness. But as we went through it, here's a little bit more on that. And I'll cover in a few more slides, but I really liked how it had us do the asynchronous processing. So I've done a lot of work with threads in the past and semaphores and things like that. And in a semaphore threaded model, you can get away with a lot of bad coding. With an actor model, I guess it takes a little bit more work to do bad coding. That's kind of a joke, but you could do it because you can do it still as a background. But if you do it right, it forces some really nice coding styles, which allowed us to, without a lot of code, it's got to be a couple hundred lines of code to really bring in a whole new way of programming. This wasn't anticipated when I first started working with these. And as a backdrop, I look at the competing products too, and I felt that Akka.net was well supported, easy to use. And it got running really fast, got productive really fast with it after we did some spikes on the other ones. Anyway, that's I didn't mention that, but anyway, so that got us to here. And then jumping into the design a little bit here too is, I just pushed that button there, but with the large cache is, I came up with the rule along the way of, if I make all these threads readers except for one, excuse me. See, there's all of our components need data from other components, because if you think of how the cloud and security works, it's all connected. So especially in the cloud, everything's right there. I mean, every service you could ever have for a large company is all connected, and the admin could be admin all of them. So we really have to have a lot of connections. So our threads, our actors are always checking on each other's states, because if one state changes, it affects my state, then everyone who depends on me, their state also changes, and it could go back to the person that affected me and change, and it continually goes like that. If that makes sense. So every little change affects potentially every actor, so it has to check. So we ended up making a large cache that's backed by store, but by making each one actor of all the hundreds picks one thing, and they're the only person that can write. So you have one write actor and everything else reads. It really made that really, really simple. So if you want to write something, you have to just channel it through that one actor. So what I mean by write something, for instance, there's users, there's how a user logs in, when a user logs in, what rights do they have? Those are all different actors. Every aspect of Azure we broke down into an actor. We keep breaking it down, so it's super granular. So a user is a member of a group, computer group. That's two actors in a simple case. and then they log into an app that's another actor, but that app actor references many other actors. So it's every action is very complex, kind of like dropping a pebble in the water, whatever it might be, but it has a lot of ramifications. But by again having only one of them right, it really simplified, and then we just keep reading the data. I did have a notification algorithm at first, where if one thing changed, it would notify the rest, but it just overwhelmed the systems with notification requests, because one thing would change another, and it just got out of control. So everybody just kind of pulls their cache data. It's super fast for the most part, unless it's cached out, and they can make a lot of decisions that way. And we make decisions over and over again, because one thing changes, my results change, everyone depends on me, changes. So I update my part of the cache. Everybody's always waking up and reading their part of the cache. That's how we work. There's more diagrams on this. So I kind of jumped ahead. I did talk about what we learned when we did do it, but the big thing was, well, first of all, making it robust. That was like a day's work, and that was because I had to spend a while just getting things to crash to test. But the asynchronous stuff, and we do reuse. How we get that code, the lines of code so small is, and this took a few iterations, like 6 months of iterations, but there's base class code that's what our actors are. And so we can run hundreds of actors just with a loop that fires them up, and then the data is different for all of them. So by doing this, that's how we get a lot of code scale. What took a long time was at first was clearing, because when we call remote API, it could take them 2 minutes to come back, and we don't want to have, I think there's mailboxes or potentially timeouts. So we took the route of we buffer the messages and then play them back, and that's worked really well for us. But traditionally, I guess maybe it's me, but as programmers, we don't break our tasks down small enough. So it took me a while to get read-only messages, first of all, so they don't change. The messages can't change in queue. And of course, in C#, it's all reference-based, so it's easy to change. That took a long time to understand what was changing and not changing. So it made really simple messages was the big one. And then getting the classes small, but we could never get them small enough with remote APIs. We just don't know. And we retry till we get the data. So we time out and retry because we have to get that data. Remember, we've got hundreds of things going on. So if a couple are slow or don't get quite their data, we probably have it in the cache from 5 minutes ago or something, but we have to wait. So we did everything with background tasks, which was took me a little bit of time to figure out, but once we got that going, it's really easy. So everything we do is a background task as a rule. That way we never have to worry about the how long it takes. It's very rare that we don't do that. Anyway, that's what we did there. I touched on the reuse already. So we model, say we don't do this, but say we want to do a printer, just because it came to my mind. We would model the printer, and the printer probably ends up with a couple other actors inside of it. But we would do that we would model the printer in a few lines, but then all the actor code or actors code around that printer would be reused. So it's really fast to add in new logic in this model. So it worked real well for us. Okay.
That's great to hear.
Do you want to interact at all here? I keep flying.
Oh, no worries. I was thinking, so I was thinking that based on everything you've described so far in terms of the long-running tasks, the asynchronous I/O, and the fact that, let's say, you have lots of objects that affect other objects, which I kind of view in my mind as like a bunch of pub-sub sort of relationships between different objects that are owned by actors, where one actor processes an event that updates its state, produces events that get broadcast out to other, and basically have a whole graph of objects that are continuously interacting with each other there. And yeah, actors are a perfect fit for that. Trying to do that using, as you put here, semaphores and critical zones or critical regions and sort of other thread managed code would be next to impossible. That'd be very expensive to do.
If you bill by the hour and you're a high price programmer, then you should do that. And no one can touch your code afterwards, so you have a job for life.
Yeah, I could totally imagine. But I think this is I really appreciate how you've broken down here how Akka.net made your development experience a lot simpler than it would have been had you stuck to the tools you knew. One of the things that I think probably the most expensive part of kind of adopting the actor model is that it requires a new way of reasoning about your software. But once you get it, like you said, the benefits really kind of speak for themselves. So yeah, no, this is great. Please, by all means, please continue.
Okay, good. Yeah, it was unlearning, and then it's, at least from my experience for engineering, at first I don't know what I'm doing. It's all complex. And after a while, you figure it out. Then you should take one more pass to optimize your code while it's still all fresh, and then freeze it. So right now, our Akka.net code is frozen, and hopefully, it just keeps on going like that for us. Right now we share information via a cache, so that's how we would say we wanted to go to we don't cross network boundaries, so we don't use that part of your product. Maybe we will someday, but we're in a phased approach.
So it all runs in a single process today.
Yes, and then if we did run two of them, I think we would take our cache and use like a Redis cache, and then we would post in the cache in the pub/sub model, like you said. Probably how we would do it right now, only because we don't know any better. I know you mentioned a lot of the new things you have for running across processor boundaries or whatever. That would be new for us, and that would be our next step for us.
Got it.
Okay, good. Here's what we do. So one of our customers calls it the Senserva bot, so I threw that brand in here, but just a bit more detail what I talked about is, I'm just trying to think of a good way to say this really, but one of the keys is that we want to take in any data from anywhere. So we talk to a lot of different people. We're focused on getting their security data, but everyone we talk to is got a different need. It's kind of interesting. And so we have to have something that's very generic. That's why we say any data from anywhere to anywhere, because we have everyone we talk to, we're getting different data. I mean, it's like I said, it's this list I couldn't even keep up. We're doing I don't know if you know Ninja One, where that's one where we just signed about to sign an agreement on. So we're adding in that's a non-Microsoft one, but it's used by MSPs, MSSPs, or MSPs to manage Ninja One. And so that's just an example one we just added. But so any data, but then also everybody has different needs. Hands-on people, security experts, they want Sentinel, but a lot of people we talk to just want an answer. They just want to say, thumbs up or here's your score. So that's a newer area for us, because right now I have the green there on the upper right where it says Sentinel. We're focused on analysts that are chasing problems, security problems, and then we want to head is a lot more reporting that just really rolls up the data. So what we found in the marketplace is that people, it's true for almost any product you ever imagine, but they just want us to have one big button they push and then they get one answer. And so we have to take all this data and correlate it. That's quite a bit of work for us to really have to understand all the data and then make a concise answer to people that's dependable. And that's where we're headed with our technology. I think I'm going to probably skip this because TJ is going to go in a bit more depth. It just kind of gives an idea. So here's just kind of a recap of how we do it. So there's infinite data coming in, and it's amazing amounts of data. It's sometimes documented, but usually, even though I use an ellipsis there, usually how data gets documented is there's a small amount of data that gets documented, and then the data comes in and it's not documented. It's just how it is. The data changes too much. And so what we have to do is we study the data, and you have to really like to look at the data because it takes a while to figure it out. So we study all the data, and that's what the fire hose comes in. Then this just kind of gives, this is a soup, there's all the ellipses, just like the documentation, right? Because for us to draw what we had, there would be, when I first did this deck, I did all the dots and it gets too confusing, but this graph that we have here would have 100 of these easy, and then there could be 1,000 users. So right now, a design point is we keep users together and iterate over them because we only do what's changed, and most of the time users aren't changing. But we could have a design someday where each user gets a thread. So we have to really be mindful with our architecture that we could easily have 1,000 actors going. And they could be not always lightweight. We don't know if our call may take if it takes 5 minutes because we have to retry and sleep and retry. So you can see how this thing could scale out really big, not even on a very big network. So that's our architecture.
So this is using like the child per entity pattern in Akka.net to model each one of these discrete entities and their own, let's say, like domain-specific actor that knows how to query the appropriate Azure APIs for inspecting things like a Active Directory user group or querying a specific Azure resource on the network somewhere. And you can kind of see how that naturally fits into it can be expressed really well in the actor model, that way of being able to reason about how you partition all these different units of work that all have their discrete, let's say, sort of needs and requirements, all within their own, independent actor types. So I think this is a really kind of elegant way of kind of sort of modeling your domain with actors is thinking about it in terms of these very, bounded contexts. So we've got this whole unit for handling Azure Directory, you've got another unit for handling these different types of devices, and so on. So feels very intuitive to me, and I'm as it is for I'd say most Akka.net users. Kind of
okay.
Yeah.
Good. What's nice thing I mentioned, users right now are one actor for us, but if we broke that down and said no, every user is an actor, and you have 100 users, whatever, the model doesn't really change here. If you did that, you would have 100 user bubbles, maybe. If you had 100 users,
Mm-hmm.
And every time you add a user, you would add another bubble. But nothing else would change in the whole architecture. It's all isolated like that.
It's great.
Nice. So you can continually refine things. So every actor should be no more than one line of code. How's that?
I think that would result in a lot of unnecessary overhead, but yeah, no, I'm with you.
One really big line.
One really big line. There you go.
Okay. So here's more. This is also this is just, I guess, another version of the narrative we just talked about, but it breaks it out more. And any of these can fault. So we might have bad code. We do. So what we find every time, not every time, but often you get a new network and the data comes back in a way you hadn't anticipated. So you've got a lot of exception handling in your code, but there's a good chance you're going to, hopefully our code doesn't fault beyond a localized component, but it could, you don't know. And of course, we'll just restart. There's always a chance it's going to take the exact same code path and crash again. And so I think we do it like 30 times, and then the whole system would keep running. And at that point, we'd put a message out, and we would have to, someone on our team would get notified then, and then we'd have to look at the logs and figure out, because because we're all data driven, right? And it comes back like maybe there's always data in this particular field, and now there's not. And we usually check for nulls, but let's just say we forgot to in this one, and it throws. It's super robust. It's a big win for actors. That's what this is here for. Crash. I got these slides from someone else, so.
Well, they look familiar.
But there you go. There's your crash and restart. That's a really important thing for any software, especially if you're hosted, this crash-proof thing that's just there for free. You could dictate different levels of recovery. That's a giant win.
Yeah, absolutely. Actor fault isolation, particularly if you're working with, let's say, third-party APIs, is very useful for being able to keep things going without there being unintended side effects. Absolutely.
And it's no work for the
Yep.
programmer. I mean, it's set up a little bit at the start, and it's pretty nice, very very nice. Um, we make a this was a training exercise for me, is clearing these fast, because again we're unpredictable. Then we do them in the background, and so then we run in the background, and then we post a message when we're done. And that, so we never stop. Our mailbox doesn't back up that way, not for very long. So these things could. So sometimes I turn it on full blast when I'm testing, and I let it run overnight. I kind of forget. So it's really, there's no timeouts. It's going as fast as it can in loops, and the system works fine. It's kind of nice because I know it's backing up. It has to be backing up. But one thing we do, if I have a task, yes, I use the message handlers. If I'm in a task, I don't start that task again. That's right. Right, Aaron. So
Yep.
yeah. So I don't, that helps us a lot in that we're for sure backing up our tasks, but it's an orderly, I don't care if they're linear because they're just checking, and usually the check says nothing's changed. So I could back up 100 of those if I needed to. But I'm also running long running tasks. Sometimes we forget, I think, in the actor messaging system, you can run long running tasks that way with very little effort, right? You don't have to clear everything within your timeout tolerance. So
Yeah.
that was a good discovery. Is that commonly used?
What commonly used? The idea of the
Long running tasks in the background.
Oh yeah, absolutely. So there's a really common pattern, particularly. So we have a lot of customers that use Akka.net for batch processing. Good example of that. We have a lot of customers in industries like asset line management, that's kind of like a CFO function at banks. And this involves taking a portfolio of mortgages and comparing them to the previous month or quarter's performance. And that's like everything has to be analyzed against everything else. So it's like a many to many type of analysis. And then you might also have to do that comparison across multiple portfolios of mortgages. And it's a long running calculation that you can only do at the end of the month, and you need it basically ready by 1 or 2 days into the next month in order to do it. So it all has to get done all at once. What they'll typically do is if they have to do a data import process, let's say they're getting origination data or they're getting mortgage servicing data or whatever it is, they need to in order to actually run the calculation. You'll have an actor that basically manages something like a bulk SMTP, bulk FTP, excuse me, like a bulk FTP operation to go ahead and download a bunch of CSV files that then all are going to get processed by other actors once that's done. But the actor managing that big bulk FTP operation is probably going to sit there, have a task and a cancellation token it hangs on to. And if we get an instruction that, hey, we actually need to cancel this job and restart it, it'll go ahead and abort that task, stop the FTP operation, and then, basically the reason why you have the actor hanging on to the background task is so it can receive that interrupt if we need to cancel it. If the actor is waiting on that task, then the only way to actually abort it is to kill that actor. You can't do anything else to control the job that way. So that is actually a fairly common pattern that you see, particularly in sort of batch-oriented systems.
Okay. Well, yeah. Oh, good. It worked out well for us.
Good.
I mean, do we talk about messages work, or do people know? Or
I think people get that much.
Yeah. It's a great build. Whoever did these slides did a really good job. It wasn't me. Of course, it was Aaron. But so this is an example of what we bring together, just kind of another recap. All the different things, and everything here is always changing. So it's a good visual. trying to think if this is a good time. TJ, do you want to just take over here?
Sure. So, like, one of our case studies that we used for the system was with Secure Sky. They provide managed security services to their customer base, and we work with them to build out a simulator that I think was on the previous slide on around conditional access. One of the things that they saw is that everybody recommends to use conditional access within Azure, but there's so many different aspects that go into how conditional access is applied that even if you're using conditional access, you may not be using it to its full potential, or you may have, worse, incorrectly applied it. So what we're doing with the simulator is bringing in all these different aspects from the cloud as a whole, which would be your users, your roles, your devices, applications, all of these different aspects, and running it through the simulator. And we call it a simulator because we're not just looking at, say, event logs or configs and trying to match up things, but we're also running scenarios through. So if you have a user account and it's an admin, for example, that doesn't work at your company anymore, but the account is there still and it has all the permissions still of an admin, someone just needs to get a hold of it and bypass all your conditional access policies and can run amok on your network. So being able to show all of those different scenarios and where the rules can match and more critically be bypassed based on the access of the user and how they're doing the access can give you what the scenario is and how to remediate it. And that was what we worked with Secure Sky for, is building out this tool, because they had seen instances where conditional access was being used by one of their customers, but there were still breaches possible. So being able to build something out for them and for our user base and our customer base in general to show all these conditional access scenarios was a great fit. And having the actor model with ACA was great for that, because we have so many different data sources and it all comes from each one's actor and into the assessor, which runs as its own actor. So anytime an actor updates the data set, the assessor actor can rerun and reanalyze the results and show any changes across the network. And this was something that we built out to kind of visualize the data. As Mark mentioned earlier, we built out and send data to Log Analytics Workspace. And this is a workbook in Log Analytics Workspace that is built to bring in the data and visualize it. And the story around the dashboard here is around user access. So you can see, specifically what the user coverage is around all your policies, how they've changed over time. You can see events that occur, and probably a good metric for showing where your critical users are is who is excluded from your policies, how many policies they're excluded from. So you know exactly how many users are, like how many high-risk users you have.
Aaron, Aaron, do you output in your new stuff you're doing for Azure? Do you output to the Log Analytics Workspace? Status?
So we have right now with, let's say, our SDK bin platform, we do use Azure Application Insights, but we actually don't use the log analytics very much. We use a log aggregator called Seek, which is the product built by the guys who made Serialog.
Oh,
So
sure.
we use that primarily for powering alerting is primarily what we do with it. No, we don't use the log analytics workspace much. Although I have done I've done an Azure dashboard, like an Azure Monitor dashboard template that does use these queries and everything to go ahead and visualize. Here's how many nodes are in your Okta.NET cluster. Here's how many messages per second you're processing, that type of thing. But this looks really cool. I could totally see why someone who was interested in understanding the application of their security policies would really find value in this. This looks great.
Yeah. If you ever did use it, these reporting tools are all built in. So
that's very cool.
Yeah, to the LA workspace.
Let's see. And then this is kind of a deeper dive on one of the widgets, specifically on excluded users from policies. So you can see kind of the query that's being run and the high level data that we're pulling out. See, and then you can just see the visual there. But then if you want to see specifically what policies they're not being applied, you can run another query through the workspace to get specifically what queries that there are.
Very cool.
Yeah.
Alrighty, and then another of our use cases was with Netrix, and what their challenge is they run security workshops with onboarding customers into Microsoft's Defender space. So they would turn on the Defenders, they'd let them run for about a month, and then at the end, one of Netrix security engineers and one of the admins from the customer would work together to gather up data, do the analysis, create presentations that would be presented to your director levels. And what they were finding was that it was very labor intensive. It was a lot of data that would get processed, and it was being done by hand.
Oh boy.
So what we did is built out a custom solution for them, and bringing in all the different data from the Defenders, and doing all the data aggregation, data analysis that they were looking for, and putting it out directly into a presentation that would get presented out to the directors. So that whole process, bringing the time down of security engineer for Netrix and admin side of saving at least 4 hours of time for each side, and Netrix is doing at least 100 of these workshops during the fiscal year. So you can do the math there on just how much.
Oh, we lost TJ. How much time was saved?
I think. Oh, there we go. I think he's back.
Okay.
Did you lose me?
I think you got interneted for a second there.
Yeah, it buffered there for a second. Apologies. I think let's see. We were talking about time saving. So the time. The Netrix security engineer and admin from their customer is saving at least 4 hours of time just number crunching and data gathering. And when Netrix, sorry.
And this is the part of the workload that's all part of Senserva's Okta.NET application is the data gathering and the number crunching, right?
Yeah. So a lot of ease there, because coming into this project, it was, we had Defender data as part of a roadmap, but we hadn't done a whole lot of investigation into it. And with the actor model there, we were.
I know I was filling the blanks. It took us probably about 40 hours, maybe 60 hours total to add all this in because we had the model. So I'll cover that for TJ. We got you, TJ. We got you though.
So bringing, and it was only it was as simple as just saying, okay, for the here's some more actors and data to pull and throw it in the mix. It was super great, super simple to do, and it made our whole product.
It's too bad TJ's internet's not using Akka.net. That's what I'm saying. TJ, I'm gonna go keep moving. TJ's had internet there, it seems. Even though he's at the home of fast internet.
Don't feel bad, TJ. I was speaking at my first in-person tech conference in 3 years a couple of weeks ago at this conference in Florida, and the projector overheated and crashed on me in my first room full of people I presented in front of in a long time. So, you got to do a little bit of fault tolerance when you're giving a live talk,
I'm the fault, he's the tolerance. Okay, TJ, I can keep going here if you want. This is just another look at the data, right? And this is with, get my glasses on. This is with Python, right? So we also support Python in, what's that product called?
Is this a Jupyter notebook?
Jupyter, yes, thank you.
Gotcha.
We have extensive Jupyter notebooks too. This is just taking the output data from this. So our work with Akka.net is all batch and runs in the background, and then we just render the data in different ways, pulling it all from the Log Analytics workspace. And one other thing from the Log Analytics workspace, that's also our API. So there's an API that calls this. That way we don't have to secure an API. Microsoft does the security of the API. So securing APIs and all that, it's just a lot of work, and you have to get it right as best you can. So that's helpful to, in general, whenever you can. You're using Microsoft storage, that's their API, instead of your own API. That's always what I strive to do. You can't always do that, but it's kind of nice to do that. And that's what this does. So there's different ways to look at the data. Blast radius is really interesting. That's an area we do a little bit now, but it's going to be a lot more research over time. So if Johnny has a problem, who else is like Johnny? This other person, they have a lot of attributes like Johnny. So go there next and check that account or make that person log in again or something. That's what blast radius is. And it's real important in computer security because in the cloud especially, there's this big giant haystack, and you have one problem, which is a needle. Where's the other needle? And computers can find that data, at least give you hints, and then human takes over. It's when you start running our system, as a human, we can understand one thing and then maybe another thing. Well, computers can do with 1,000 things. So you do your algorithm where it's like, okay, this is very basic, I understand it. Now turn it on for everything. In the computer, it isn't really artificial intelligence, although some say Google has it already, but with sentient beings, but they get fired if they say that, I guess. But it's amazing what happens when you turn on, say, 100 different threads that are interacting with each other, because our brains, we can't do that. We get like short-term memory, maybe 5, give or take, things at once. But computers doesn't have that limit. So it gets really quite interesting when it fires up. And this data, pulling this data in Jupyter network or notebooks, whatnot, can be pretty interesting.
And we've got Thomas back.
Okay.
Yes, I am back now.
All right.
I covered blast radius. This one is Thomas. If you can cover this one, I look at this. I don't know what the heck it means, but analysts look at this and they really like it.
Right. It's a Python networks graph, and what it's doing is it's visualizing the blast radius as a graph, and so it's set so that the nodes that are larger, that are darker in red, are going to be the higher risk nodes, so that the bigger you are, the redder you are, and the shape of the node denotes what kind of node it is as well. So, and the and the
When you connect, you're tainted, right? So if you're connected to red, you're at higher risk.
yeah, and so that's kind of where more of the blast radius is. If you think of the circle there as kind of like the epicenter of the implosion, then the nodes around it are going to be part of the crater. So
Got it. So this is like you basically detect that this account is not in compliance with one of your policies, and these are all the resources that might be tainted by that, right?
exactly.
Got it. Okay, that makes perfect sense.
And this is always changing, always moving around. And with Python, you could do it fairly interactively because you write all the code. So, every few minutes, you could do it every second, I guess, but every few minutes this would change.
Got it. Well, so basically, so if I understand this correctly, so your product queries all of the actual objects directly out of, let's say, Azure Active Directory and other resources on the network, and then your product is what emits all the logs in a specific structured way that can be used to create these notebooks into the log analytics workspace, right?
It goes in the log analytics workspace, and then we take an API and take it out. One thing about this data is it's streamed. Log analytics workspace is streamed. It's an event data.
Mm-hmm.
We don't always have event data, but we stream our data as it is an event. Most of the tools security people use are event driven, so we want to dovetail into that. But it's time. So we can say, at this point, this is your state. At this point, this is your state, over and over again. But then you can start. That's how you get trends in the data. And the data can last 90 days. It can last a couple of years if you want to pay for the data. But eventually, its usefulness kind of ages out. But by streaming like that, you get a lot of power because the data never. It is like a database table where you update the same record and maybe have a date of the last update. Here you have the records never go away. They push off the edge of time after 90 days, and there can be duplicates in the data, and you just account for that in your queries. So it's an interesting way to look at data, if you call it temporal, whatever. That's what this all does. I don't know if that makes any sense, but
makes sense to me. Is that you can see how things change over time and what the state of your security was like at this period of time too, which is really useful for doing things like incident review, for instance.
Yes, in any given time, you have all your data and all your relationships. So you'd have to write the query, but you could set a time, a little slider or whatever, and it would tell you your exact state. Because like you said, incident. So one of the things companies have, if there is a suspected breach, let's say an employee took proprietary documents, and then you say, okay, what else did that person have access to June of 2019, whatever it might be. If you have that data, and bigger companies can save that data, it's not that expensive. You could set your time to that date, and you'd have a really good hint of what rights did they have, what could they access, and maybe if you have logs for what did they access, and now you know what's at risk, and take your point there. So that's real important data. I think you don't always have that data, and with products like ours and the log analytics workspace, it's achievable, and the cost isn't that high. For the data can be maybe a little slow, although it's very fast. Theoretically, it's a little slower because it's a little cheaper, but that's another nice value of using a logging database versus a relational database.
Don't need to sell me on event sourcing. I'm a huge. That's all we do around here on
Okay.
Audit
All
Persistence.
right.
But no, I'm with you 100%.
Yeah.
Well, all right. Well, first, I want to thank you guys for your presentation. Really, I thought it was very fascinating. I'm not a security expert by any stretch of the imagination, but as a CEO, and I do have to worry about access control to sensitive resources, I really everything's clicking for me in terms of how Akka.net plays a pivotal role in helping you perform this continuous audit of resources, and the notebooks that help visualize the output from that auditing so a human being can actually step in and do something makes a lot of sense. So I kind of have a complete end-to-end understanding of your product now based on what you've shown that I did not have before. So thank you very much for that.
Great. Thank you.
If there's any questions from the audience on this, or Gregorius, if you have any, let's have the Senserva team take them.
No, not for me. I mean, it's really interesting, but like you said, I'm not a computer security expert myself. I mean, it's a really cool field to work on, but
well, it's the big benefit I see is that things are always in flux. Like, good example, you have Active Directory policies or that are time sensitive. Good example, like a password reset policy, or maybe you just enabled 2FA and you can measure how many people are out of compliance with it. Or let's say someone gets moved from one part of your organization to another. It's like, did we reapply all the security policies in order to be compliant with, let's say, PCI or what any of the other policies we need to work with? Being able to go ahead and kind of get that continuous view of, let's say, how, and also being able to go back in time and see if we were out of compliance at any given point in time, and if we need to disclose that in order to basically maintain our regulatory sort of good standing for being able to handle certain sensitive types of data. I can see how a product like this would be extremely useful for doing that. And I really appreciate the insight that Mark shared with sort of how actors were able to greatly simplify the development process for doing this. So if I understand correctly, the way you actually deploy this to customers is basically as like a standalone like application running in its own virtual machine, right?
We deploy it exclusively, unless it's for a special case, but through Microsoft Lighthouse, which is so it's kind of an interesting, nice technology to touch on that. So we have a template, and you install, and it just all it does is installs an app service. It installs a Key Vault, and then we ask the person to create an app, because right now it's targeted where they control the product. We don't, except we can update it with Lighthouse. So whenever we do a rev in our DevOps, we can push updates to everybody instantly. So you still get the benefits there, but it's in the customer's tenant, and they control like who has access to it. It's just super paranoid security stuff, but it's lightweight, stuff like that. But so it runs C. It's like we designed it to be Windows has services. It's designed to be a Sentinel, not a Sentinel, but an Azure AD service that just runs. It's just always there running, producing predictable data. And then we update it remotely using Lighthouse. Lighthouse is interesting in that we do want to protect intellectual property, because anybody can install our software, and we rather reserve the right on that, unlike you who are open source, because I don't know, sometimes with security stuff, a lot of people open it up. I'm just not at that point yet, because if people know what we do, then they know what we don't do and how we do it. So that's a little bit like that. So by running with Lighthouse, people cannot reverse engineer our code. If we did it with like a distributed VM, or let the people create something, an app service, they could get at the.
Got it.
And you can encrypt it and hide it and this and that, but the people who reverse engineer stuff are really smart, and they figure that stuff out. So you're going to eliminate some people, but it just takes one person, and then there it is on the internet anyway. So, but with Lighthouse, you can't get at it. I think that's why Microsoft designed it that way, so you can hold back on proprietary things. It's a good thing to know about. It's not that hard to do. We are a Microsoft partner, and we have to get they do check things to get the little ID. It's called some sort of ID you get on your app. They check that your company is real and all that. They do accounting checks. I don't know what checks they all do, but they do validate you. And then this is just for education. We will do this. We are coming out with a SaaS version right now. This is an embedded version. But if you follow a number of rules, which I do not know yet from Microsoft, then they will give you a star, if you will, on your app also.
Oh, good.
So the big challenge in the industry is that security companies are getting breached. And security companies tend to have access to all the data. So if an unwanted person breaches a security product, they tend to get a lot. So the bar has gotten quite high on security products. So
it's kind of ironic, isn't it?
It makes sense, from a it's not good, but yeah, we do have the data, so we have to be doubly sure, keep doing our best for sure.
Well, Mark and TJ and Kevin and Kyle, thank you very much for your presentation. It was really interesting to hear about the Akka.net being used in the security industry.